In lesson 5.5, we are kind of expanding our knowledge of solving a system of two linear equations and two unknowns to now three linear equations with three unknowns. And if you notice here, you can do this algebraically. As it reads here, the solution method involves multiplying two of the equations by the proper numbers to eliminate one of the unknowns. And then we repeat this process using a different pair of the original equations, being sure that we eliminate the same unknown as we did between the first two pair of equations. At this point, we have two linear equations and two unknowns that can be solved by any of the methods previously discussed. Okay, so let's see. This is what that looks like. So we're starting out with these three equations, 1, 2, 3 listed at the top. And then what we're going to do is take equation 1, multiply it by 2. So multiply everything in that equation by 2. Then take equation 2, and we're going to add those together so the y's cancel out. And that leaves us with 10x plus 12z equals 13. Then I want to do the same thing with two other equations. So I'm going to take equation 1 and multiply it by 3. And then I want to take equation 3 and combine those two together by subtracting. And that gives me 18x minus 3z equals 7. And now everything kind of collapses into two equations and two unknowns. And so I want to take the equation 7 and multiply that by 4, so I can add those together and get 82x equals 41. Divide 3 by 82, so my answer for x is 1/2. And then I can go back and plug in 1/2 in one of the previous equations and find the answer for z is 2/3. And then go back and plug that into one of the previous equations, the 1/2 and 2/3, and find out that my solution for y is -3. So my final answer is x equals 1/2, y equals -3, and z equals 2/3. Now, even though we solved that system algebraically, we could also use our calculator to help us solve that system of three equations and three unknowns using something called the reduced row echelon form feature. And so let's go through an example of what that looks like. So what you do first is you write your system in standard form. So we've got our system of three equations and three unknowns in standard form. Now notice there's not a y value here, so we got to be careful with that. So we want to construct a matrix with 3 rows and 4 columns that include the coefficients and the constants, but not the variables. This is called an augmented matrix. And we're going to insert zeros for the missing terms. Okay, so notice we're missing that y, so we're going to put a 0 in there. So this is what the 3 by 3 looks like, but we're making it a 3 by 4 matrix, so we're using the -3, the 2, and the 3 from the 3 equations and putting that in the matrix as well. Then we're going to use the row reduced echelon form feature. This can be found in your calculator under matrix. Go over to math, RREF, and then put it in front of the name of the matrix that you're using. So it kind of looks something like this. Let's see if I can make this a little larger for you to see. Okay, so it ends up looking something like this. RREF of matrix, whatever name you call it. And when you finish with that, what you end up with here first at the beginning is something called the identity matrix. But those three numbers are our solution. So our x is -1, y is 1, and z is 3.